unscripted remarks and probably poorly structured remarks on platform trade-offs here. But as in most of these things, I'm hoping that most of these cases, I'm hoping that they'll offer some modicum of value, um, although they'll be very limited. So I'm gonna again speak from authenticity here and from my considered assessment of the situation, having spent virtually all of my adult life interacting with agent-based models. I started my serious research journey with them over 35 years ago. No, it's about 35 years ago, within a few weeks now. And it's a journey that has taught many lessons. To be frank, I'm very disappointed indeed on the current state of play with respect to agent-based modeling. I personally think the support for it is extremely poor compared to what it could be. I think the existing frameworks, including any logic I might not, impose many needless barriers to transparency, needless barriers to performance, needless barriers to modularity, needless barriers to composability, needless barriers to adaptability and extensibility, needless barriers to interchangeability of models, needless barriers to team use, and I could list a variety of other shortcomings. But I prefer, rather than a deficit-based approach of sitting on the sidelines and throwing brickbats, to talk about some of what I see as desiderata. And I will share with you a slide, which I'm not going to, given the limited time, into respect of all of our weekends, I'm not going to speak about in detail. But in my mind, what the field needs, what the field deserves, and in many respects, what the field wants, tacitly or implicit or explicitly, are ABMs that adhere to some basic properties. They're declarative. You specify what you're wishing, not all the details of how. There's domain-specific languages that allow you to express it in a natural language, not in a general-purpose programming language. It has rigorously defined mathematical meaning, so it could be transformed, analyzed, optimized, parallelized, mapped to different interpretations. It supports modularity, both with hitching up different models, different pieces of models to one another, and hierarchically in a multi-scale context. It's performant, taking advantage of parallelization within a machine and between machines, and quite possibly use of GPUs. Has a strong typing and unit system. By that, I'm also including dimensions, like we've seen and reasoned about in many contexts, like in system dynamics, but also in buildings models, but which are terribly under-supported. You can build up a model and with sort of interlinked abstractions based on a domain, rather than these piece-by-piece fragments in which we're building them. And where we separate observer processes, these things are report on a model out from the model, the core governing dynamics of that model. And those observer processes should themselves be specified in a way that adheres to certain properties, including all those, or, declarative, mathematical meaning, etc. It should be modular. A given user, if I run model as a core modeling team member, as a core person is involved in some of the technical architecture model, I should be able to see different reports on model behavior at a flick of a switch compared to, my infectious disease specialist colleague, or someone whose primary focus is on contact tracing, etc. We should be able to have different lenses with which we see them, and different levels of reporting on that model that we can turn on and off at any point without modifying the model. There should be a separation of the form of the model from the semantics. I spoke about this this morning, and my conviction remains there, although the participant is no longer here. The observation here is that we can often interpret a given diagram in many ways. There should be different interpretations that make themselves possible for things like running the model again and again ensembles, or running it once, or running with sensitivity analysis, or running with calibration and particle filtering, etc. And things that summarize its structure, help us to understand it better, cross-check it, test it. There should be the ability to compare results across scenarios, ability to make explicit things that are associated with interventions, and it should support teams, interdisciplinary teams, which typically lie behind impactful health interventions, behind using models. And it should have good support for the technical side of that team, with things like version control, those directly involved in evolving the modeling, semantic versioning with it, the capacity to test it, to validate it in ways that help us develop confidence it's working properly, help us mock out portions of it, as has been described with sort of partial model testing. All these things are things that I think are key advantages within the space. And sadly, while the situation is better than 35 years ago when I started building models in the programming language Forth, or even earlier when I was doing work with assembly language, the state of play remains yet far from this for existing frameworks. I will note that I am pioneering an experimental framework which addresses the large majority of these. And I hope within my professional lifetime to deliver on a framework that delivers on all of these, likely an extension to that, a refinement of that. But today's frameworks leave most of these unchecked. Never mind the list incomplete. And I cry for it. I mourn it. It makes me profoundly sad that over my 35 years of professional service, this is still a job undone. When I could sense so many of these, probably a good half, when I entered grad school. And I regret that I didn't work on it then as my dissertation work. But I'm determined, in as much as my health keeps up, to address these needs before I retire. Now, I want to talk about the extant state of projects here. And my remarks here are somewhat antiquated, but I'll ad lib where they don't address some important contemporary projects. And again, I don't like to take a deficit-based approach. I know how much effort AnyLogic has put into work. I've met their key developers. I know the developer of the ABM, the CRAN's ABM package. I was giving a talk jointly with him last night, and he's a friend of mine. I count him as a friend of mine. I respect his work deeply, the creator of the main CRAN R ABM framework. I've met the co-creators of the Repass framework. I rubbed shoulders with one of the key people involved in launching that logo back when I was first experimenting with ABMs when it was called Star Logo. I have a very good collegial relationship with the creator of the ModGen framework. I've extensively made use of the AnyLogic framework, needless to say. And our lab has made some significant use of the Julia framework. And we have a close colleague, Jeff McDonald, who has helped, by extension, do a little bit of shaping of a sort of minor foray into the space with InsightMaker. What I understand to be minor. Maybe it's developed a great deal. And, we could take some of these platforms and we can compare them. And I need to extend this for the RABM package and agents.jl to make it really contemporary. This is a Julia package, which again, we've used. I therefore have quite a lot of experience to talk about, to draw on. And I will tell you that I think all of these packages, have some good size to them. I should actually put in here, I'm sorry. There's another framework. Oh my goodness. There's another framework which really should be on here. And I'm trying to it's the name slipped my mind just now. Forgive me. But I'll add it to this. So it's a Python-based framework. What do I think about? Look, each of them has some trade-offs, and I've added some here, and as I see it, and I'll add more, and maybe that will offer some value. And I make some comments on AnyLogic in particular, its strengths and its weaknesses. And I would probably update some of the weaknesses, and I would update some of the strengths here as well. I think there's actually many good things to say about it, which is why we use it so extensively. I also think, falls short in some important areas. Now, but I want to take a little bit of a meta level view. Mesa. Yeah, it's Mesa. Thanks. Thank you. I'm going to take a higher level view. NetLogo has a comparatively shallow learning curve. It's made for beginners. It has a really good accompanying book. It has some support for system dynamics modeling. As kind of an alternative to ABM. It's free, awesome. It's a quasi open source. At least you can see the source code. Wonderful set of example models. Yuri Rulinsky is an academic that I greatly respect and lies behind it. When I first saw the progenitor of it with Star Logo 35 years ago, it was 34 now, for that particular time point. A lot of experience. I had a lot of experience already with ABM, and I saw the language and I said, no, thanks. I really think you're doing a disservice to using this language. I understand why you're using it based on logo. It's based on the body syntonic metaphor. But I think you're making a mistake. I think it's an ugly language, and I think it could be done much better. They didn't listen to me then, and I still feel the same now. But I think it's an interesting language, and it's not terrible. It's based on logo, um, which at that point was quite a popular little framework for teaching kids how to use computers in a declarative way, or not declarative, but in a sort of way. I find it just a little bit ugly as a language, and I also find it obscure enough that many people, many health scientists, have trouble learning it and can't find enough references. You can't find help with it so easily. It's also very slow. Difficulties in scaling up populations and larger models can become really, 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 really challenging to understand. Repass larger models can become opaque, same thing. ModGen is also challenging there. Agents.jl is a tool that has a lot to recommend it in terms of performance and in terms of it attempts to use some declarative, some kind of characterization of agents using what are called Julia macros in a way that's less low level and more declarative. It's characterizing what I want and not how as much. But it's again accompanied by a great deal of code. Junling, I love the guy. He's awesome. Junling Ma, University of Victoria. One of my favorite modeling colleagues in this world. Wonderful personality. Knows about our agent-based modeling work, building a framework with these desiderata. Really likes it. And he's a pragmatist, and he's rolled out the R ABM package. I was on a panel with him last night, or panel, we were presenting in a conference session together. I interacted wonderfully with him. I think he was great. The ABM framework there that he's built up has many things to recommend it. Number one, it's an R. Many health scientists know R. Number two, it interfaces by extension with a lot of tools in R that are just great for working with data, analyzing the data and processing it, exporting it, graphing it, tabulating it, slicing and dicing it various ways, doing regressions on it, doing non-parametric statistics on the results, which you want. A great deal of value there. And it's one of the reasons in the past why some members of my lab, Winchell Chen, longtime lab member known as the King, in one of his remarkable feats, he had an auto export feature from any logic that would just report data from the model into R. Just astounding. I had this like pipeline into R directly that R could read all the outputs from any, or could read outputs from any logic model, and then you could analyze them. It was great. Now, so there's lots of good things to say there, and I admire the boldness of his vision. I admire his tenacity in building it up. Um, and honestly, I'm, in the current context, we obviously have made big investments in AnyLogic for our work, and that will continue because of its embrace of hybrid modeling, its embrace of declaratively characterized, visually accessible state charts, particularly, and attempts across multiple things with networks, with characterization of scenarios, with statistics, with outputs like graphs, with events, etc. It's made as good a commitment to declarative model characterization as any extant widely used framework. Again, we believe we can do far better, and we are showing it, but in this experimental platform, but with uncertain performance profile, etc. And it's some ways before full production use or anything close to it. And I think if I had to choose a second best platform here, there'd be runners up. Possibly NetLogo for first class. I'd consider gentle learning curve, great documentation, lots of widgets to make things easily for visualization, great example models to build on, good development team, etc. Agents.jl would have a crack at it because of the really strong performance and the at least attempt to commit to some declarative specification. But probably my second choice would be the RABM package from Jinli. I really think he's done well. And in preparation for this, I went and reminded myself of elements of that. Oh, my goodness. Okay, I just closed it. I prepared lots of features, but here we go. So here's Junling's CRAN ARM project, right? And you'll note this this set of models. I pulled some up here, and so I can talk about them in general. What I see here is a good faith attempt to try to simplify some elements of model construction in a way, if not fully declarative, it at least has some flavor of declarative, right? We have S plus and I leading to, so a susceptible infective leading to two infectives, right? And within the context of a Poisson random network here. And here you're setting up the initial state and running it, and you can fault the departures from declarative components, but I would note like the nice articulation separately of sort of observer processes in factors here. The nice characterization of parameter values and so on. Now, in practice, um, we have the need to accompany a fairly declarative characterization with limits, with some important limits where it doesn't quite meet the desiderata. There's not this wholesale separation out of observer processes in ways that can be enabled and disabled by user, etc. But it's pretty good as far as these frameworks go. But the fact is, in that framework, as well as many, there is this need for accompanying code that needs to exhibit some fairly significant logic at times, right? That accompanies a quasi-declarative characterization of the model. And it's not terrible, and I think it's a feature of many frameworks now that there's going to be some of these bits of extra logic that are needed that will require some programming. It's kind of low level by my view, and it is hard for me to imagine showing this, to stakeholders, even in my modeling team, who are not our users, or who are domain experts, much less community members or people with lived experience. I think it's it's not going to be helpful for communicating to them in a way that state charts would be. But it has many virtues to recommend it. And it's really tied in with the incredibly rich R ecosystem, the incredibly rich ability to have input and output from the model tied at the hip with the model. And it's free, and it's continuously updated, and it's generously documented, and it's getting better over time. There was quite a lot of work that occurred in the pandemic period, as noted here with Jun Ling, a member of the Omni group, led by my colleague Huaping Zhu, and his co-membership with me on the Mathematics for Public Health grant that we were both part of and around which we interacted. It also, it's very thoughtfully done in a way that supports many environments. I mean, for example, here, where you have household transmission in a household, and transmission in a broader random mixing context. But I will say, looking at this, but without the authenticity of having applied it at serious levels in the context of a diversity of projects, my sense is that it's very well adapted to many communicable disease contexts. When it comes to health services delivery, when it comes to matters of broader public health, broader interaction of individuals. There is some attempt to capture mobility, and it's possible that could be somehow linked in with the sort of GIS components that I've seen. Where did I see the mobility model? I thought there was, okay, I may be wrong here. But there was there's often these needs that end up being awkward fits to a framework. And my own thought is that it probably works really, really well within that communicable disease area that shaped its evolution through Omni, which whose focus was One Health, through MFPH, whose focus was communicable disease control and prevention, but may not be, a tool for behavioral epidemiology quite as much. May not be a tool for certainly health service contact, et cetera. And I'm not sure about the mobility context. I thought there was some affordances here, but I'd have to look at it. And same thing with geographic components. I think it's not a bad solution. I have many good things to say about it, and I hope to contribute to it some and to apply it. One thing I would like to do more is to compare it side by side. Some people would say head by head, but I personally don't think it's a matter of either or. I think it's a matter of figuring out where each has its real strengths. But if I could get insights by trying a couple models of diversity here, it could be really favorable to sort of compare where it builds up, where it breaks down. I will say one thing that I've observed across a lot of frameworks that I think is true here too. You notice that beyond adding like transitions in a way that is reminiscent of state charts in a really good way, we also have this ability to add loggers. But as best I've seen thus far, those loggers are loggers of the count of people in different states cross-sectionally. And often we want logging that is reporting transitions between states. And it may be that there's mechanisms for it. I'll have to ask Junling. But in the examples that I was looking at, I didn't see, an obvious component. Even here, there's going to be some software engineering burden, but I think it alleviates many of the basic things that you won't have to worry about. Implementing manually the logging for at least the current state, the current observables, excuse me, the current state of the model, cross-sectionally. Maybe you have to do some custom coding that's more sophisticated for recording number of new people that have gotten infected in a certain period of time. But at least a lot of those basics are made simple. The adding of a transition is made simple. And basic elements of evolution. So I think there's a lot to be said about it, and I think it will be my second choice among the platforms here. And the fact that it's using the R language is, I think a huge gain for many health scientists. Junling is expanding it over time. He was speaking last night about, a model that made use of, based on some other contexts I saw at the site, what I think was an ABM built in here, and I think that required some further refinement to the framework, and I think it's evolving quickly and in an informed way. I think what it does need is some people evolving it in a way that will support a broader set of models that might involve things like mobility, might involve things like geography, might involve things like multiple types of networks, might involve things like the occurrence of history dependence on a person, keeping track of history, recording state transitions, etc. But, if we go back to my desiderata here, Um, I would say, in my mind, it doesn't do too badly here. There's a bit of a domain-specific language, or at least domain-specific API, not visually but textually. Be very nice if there's a way to illustrate it visually in a way to communicate. Um, I haven't seen strong evidence of composition of models or hierarchy, but I can look more. Um, Junling has done quite a bit with C++ for performance, and in general, R's performance because its reliance on C++ backend isn't too bad. I'm not sure about the parallelism. Parallelism for eking out a lot of performance gain from multi-core is not for the faint of heart. It requires um, some pretty sophisticated approaches, and I'm not sure that's in the cards. I'm not seeing strong, type B unit system, but at least what I am seeing is thoughtful. Um, I do see some evidence of kind of domain-centric abstractions, or at least, things like adding transitions and adding loggers, etc. Nice way. And that capacity to have observer processes of some sort, like the notion of a logger is kind of indicating this is not just a piece of model evolving logic. It's not just an element of model state. It's kind of an observer process in a way that's really valuable. Um, um, I'm not seeing the separation of syntax and semantics, the sort of ability to characterize the form of a model and then to interpret it in many ways, but run it many times, run it with sensitivity analyses, calibrate it, um, analyze it from certain perspectives. But I'd have to look more. I think Junling is interested in this, in my commitment to it. Maybe at some level it will come. The ability to compare scenarios I'm not seeing, but it's eased by doing it in R. So maybe you could get results from one scenario, get results from another, and in R, compare those. Um, well, team support, you can always um certainly engineering support, you could use, Git with R as always, and a growing number of health scientists have a passing familiarity, at least with Git and doing Git version control. Um, um, I'm not seeing the visual representation side in a way that I'd like, and I'm not seeing the commitment to collaboratively doing that across teams and user custom output for certain types of annotation and so on. Recording of paradata, metadata on models. But I think it's a great choice. Um, I think it's given the current state of play, I think it's a very worthy choice to consider, and I will do my part to um to help shape it in a way that might allow Junling to know about other application needs and areas. Even if I'm not a core heavy contributor to it, I can at least talk with him about the need for for additional things. So his central role in this, I knew about it kind of peripherally, but I didn't connect it with the main or a central main uh, CRAN CRAN-based ABM support. I knew he was, like me, doing work in support of ABMs, but I wasn't familiar. In the meantime, in the next year or two, I will tell you, they were anticipating having a platform out that will address the large majority of these. And where we fell short, we'll be working in subsequent years to fill that in. And I'll certainly keep interested parties notified. But those are some thoughts on the current state of play in the edge-based modeling world. I'm really disappointed in it, but I think we're in a point of transition, and I think personally that ABM, the CRAN R package is a worthy one, and a high point in recent development that's come to the fore. I hope those comments are helpful.
Yeah, one thing I've been, I guess, starting to learn as well is that depending on the team, we might need to adapt and kind of learn different languages
Hmm.
because different teams use different things, and sometimes I guess
Yeah.
dealing with all stakeholders might depend on that too. But yeah, I
Yeah.
do see a advantage of using comparatively to R because I think visualization is nice using like ggplot and all of that. It's easy
Yeah.
to see what we want to see.
Yeah.
But I do think in terms of communicating with stakeholders,
Mm.
any logic seems way better indeed. Especially as the models get more complex, I do think might be easier to adapt as we are like, I don't know,
Mm.
having
Right.
them.
I will say, like, one thing that would add a lot to Junling's contribution is if there were a nice way to take one of these models and like generate a visual representation that was parsable, right? Like that with different levels of detail at different times, where you could turn off whether to show loggers, you could turn off the level of detail to show on the, random mixing part, or the, just to very abstractly show states and kind of transitions between them or whatever. I think if you have multiple conditions, it's also not clear to me how well it's going to scale to that. But the point is, I think whatever representation they have, I think if you could visually depict it in a nice way, even if that's not your main representation, a constant point of recurrence, if it's something you could create on demand and show to people, it would be a real asset. And that is one of the things I'll talk with him about. Yeah. Okay. Okay. Any further points of discussion on this front? We've gone over my my goal here, and I apologize for it time-wise. But are there any other points of discussion or things that people want to ask or pick up before we bring the boot camp to a close here?